Hello everyone, welcome to my YouTube channel. This is Melvin. Welcome to another video also. In today's video, we're gonna explore how Nmap performs host discovery before scanning ports, and we will analyze also ICMP and TCP based techniques such as PE, PP, PM, PS, and PA, and understand how packet responses determine whether a system is online. So let's jump into it and let's get it started. So before jumping into the practical things, the first thing which is very important is to understand the definition of host discovery. What is host discovery? So host discovery is the process of determining whether a target system is online before performing deeper scanning, like port scanning, finding operating system version, exploit them, and etc. By doing that, you're gonna save a lot of times, and you're not gonna waste of your time just by scanning the ports of the offline system, which is very useless. So before scanning thousands of ports, Nmap first check if the host is alive, and then it tries to do port scanning. This saves times and avoids unnecessary traffic. Host discovery is sometimes called uh, ping scanning, but it involves much more than just ICMP ping. So ICMP ping refers to the echo and reply request, which is the type 0 and type 8. I can show you here. Yeah, here. So echo reply is type 0 and echo request is type 8, which is the ICMP ping or ping. Ping use the same thing. So yeah, we have four major factors here. Why host discovery matters: reduces overall scan time. It means you save a lot of times. Avoids scanning offline hosts to improve accuracy, so you get the result of from the host and get the result from the hosts which are up. And it reduces network noise. The less noise you make, the stealthier you are. So it reduces network noise to stay under detection thresholds. So instead of sending packets to all the networks in your local area network or into your target and make a lot of sound and noises, and anyone finds out someone is trying to scan our ports and try to find the IP address or the private IP address of ours. So you just try to send the props and the request to those which are up. Key concept: host discovery is phase one, port scanning is phase two, and after that you can do further action like finding the version of the operating systems or finding the exact version of the service that is running on your computer. It breaks down to four stages. The first stage is Nmap sends a specific prop packets tailored to the request discovery method. So the first thing, as usual, is to send packets and prop to the target, and it's waiting to get a response from the target IP address. And after analyzing the response that comes from the target IP address, it finds out if the target is up, down, or the packet that we sent is filtered by the firewall. Yeah, this is breaks down into the fourth stage. So the first thing is ISMP echo discovery. But before jumping into that, I would like to show you three more options, which is more useful for now for the basic things. So before jumping into the PE, let's do that. So let's go to the Kali machine. I use Nmap dash help. Sorry. Okay. Here we have three important options, which is IL, SL, and SM. The first thing that I would like to mention is SL. So what does SL means? SL, if you're not sure what range of IP addresses you are trying to scan, SL gives you a big hand. Okay, so after using these options or argument, you can be pretty sure and you can make sure that what range of IP addresses you're trying to scan. So let me open another tab here. Okay, let me enlarge that. So I'm using Nmap. SL, SL, and I don't, let me mention that later. Okay, I'm using 9 to 12. So this is the range of IP addresses. This is the IP addresses that I'm trying to scan from 0 to 255. But later on, in order to use them, in order to save them in a text file and use them using IL option, so we only need IP addresses, the numbers. We don't need DNS resolution to transfer or sorry, translate the IP addresses into the name or the host name. So in order to prevent that and stop that, besides using SL, which just show you the range of IP addresses that you want to scan, we also use NN, dash N, okay? Something like, it's like that. SL dash N, and then the same range of IP address. So as you can see, there's no DNS resolution and we have just IP addresses. And after that, using methods and using command like cut, you can just transfer these IP addresses and save the output into a file. And which I got here, ls, it's on my machine, it should be targets.txt. Let me cat it. Cat targets.txt. As you can see, I have the list of IP addresses which are in my local area network. So now it's time to use -il and the file name in order to find the hosts that are up. So always remember, if your purpose is just to find the live hosts, never forget to use SN, never. Because if you don't use that, the Nmap try to also do port scanning. Let me show you. Nmap ILSN, sorry, first SN, IL target.txt. So it might take a while. So no, unfortunately it didn't. So we are just trying and we are just spotting the servers and the machines that are live, okay, or up. But as soon as I remove this argument or option here, it also does port scanning. So the same command without SN, different result, alongside finding hosts that are up, we also find services and the ports that are open and running on the target machines. I think this one might take a while. I hope it's processed soon. Come on. Yeah, as you can see, besides finding the live host, we also have the port scanning here, which may sometimes is not our intent. So and it's not our purpose. So if you only want to do find a live host in your local area network or remote server, so never forget to use -sn. So these are the three main options that I would like to mention before jumping to the main part. So now it's time to where's my now it's time to use ICMP Echo Discovery PE. So I need to mention that the PE flag sends a standard ICMP request to the target. If echo reply is received, the host is marked as up. No reply suggests the host is down or blocking ICMP. So if we don't get any response, we have two options. It's blocked by the firewall or the system is down. Unreliable as a sole method because many firewalls block ICMP echo, including Microsoft firewalls. Let me show you here in Google. Does Windows block ICMP echo request by default? Yes, Windows firewalls block incoming unless you deactivate your firewall, which I did here on my Windows. This Windows, I mean, yeah, this one. So let me come here and use Nmap, PE. Never forget to use SN to yeah, it also finds the system that are up, but using ICMP echo request, okay, which is type 8. Let me show you here. Echo request type 8, and the reply that we get is type 0, okay, reply type 0, and the request is echo is type 8. So this is PE, and the next one is PP. Sometimes, as I mentioned, like Windows firewall and other system may block ICMP echo request, so you might have other options like PP timestamps. So it's something like that, that you send a request and the server reply you with the time of the local zone. Okay, let me show you. Nmap, PP, and SN. Don't forget that 0 to we exactly do the same thing, but with different method. We use ICMP timestamp. So we send a request, and the target reply us with the local area time zone. Yeah, time zone of the local area. Sorry, time zone of the local area. And because we don't care about that time, because we get the response and we get the reply, we understand and we find out the host is up. So the PP flag sends an ICMP timestamp request to identify active system. Instead of status check, it specifically requests the current system time. Some firewalls also block standard requests but permit timestamp responses. So that's why it's like kind of an alternative to PE or ICMP request. If a timestamp reply is received, the host is identified as up. If we didn't, so it's down or it's black. But it's more reliable than ICMP echo requests. Um, ICMP net mask discovery, so we use PM. So PM sends an ICMP address mask request. This request asks for the host for its subnet mask. So subnet mask is something like 255.255, or it depends on your network, which and the subnet that you are on. So you may in a local network, but in different subnet and have different subnet masks. Okay, so for example, let me show you here for mine. If I go here and open the network and Wi-Fi and details, if I'm not mistaken, it should be something like here, TCP. Yeah, subnet mask mine is 255, 255. It means any computers that has these uh, first three octet set, like mine, which is here, if config, any computer that has 192, 168, and 12, we are all on the same subnet mask, on the same subnet group. If we share this first three octet, or this first 24 bits, or first 3 bytes in different terms, we are all on the same net mask or subnet group. That's what I wanted to show you. So let me, okay, modern system rarely respond, but legacy devices sometimes do. So if a reply is received, host is up like the previous methods, PE and PP. But it works like PP. It's more reliable than PE, which is the ICMP echo request. But some firewall also might block this kind of request. So yeah, that's it. Let's go and test how it works. Where's my calendar? Okay. So we use Nmap, PM, and SN 102. So as you can see, we got the same response as before because um, it didn't block any of this type of requests, but there are some firewalls on your router or on your modem or even your computer that blocks this kind of request. So if it doesn't, good for you, you may get a response and the host is up. And if you don't get any response, the packet is blocked or the host is down. The next one. The next one is PS. It's different than the ICMP. So uh, when we are in a local network, I would like to mention that we are using ARP request or protocol because it's more reliable. If you want just to find the live host in your local area network, but if you would like to check the status of a system or server in distance, which is remotely far from us, the best options are ICMP, TCP sync, synchronize, and TCP ACK. And the other method, ICMP timestamps, ICMP mask. These are the good method to find out if the remote host is up or down. So PS sends a TCP synchronized packet to a specific port. Mainly and mostly, it should be port 80. And sync ACK received. If we get sync ACK as a response, so host is up and uh, port is also open because when we get sync ACK, it means port is open, and because we get the response, so host is up. But as soon as we get the reset flag, so it means host is up. So because we get the response, but because we get the reset, it means the port is closed. No response typically indicates the host is filtered or down. Even a closed port proves that the host exists because it responds with reset or RST flags. This method often works when ICMP is blocked, and do that when you want to check the status of a host which is remote and is far from you. The best option that you need to use in your local area is ARP or Address Resolution Protocol. So let me go to Kali machine. No, it's not Kali. Where is it? Okay. So let me open my Wireshark, and I want to do Nmap PS SN 102. As you can see, we get the same response as before, and we found the server and the host that are up. But the thing is that I don't understand why it's sending ARP, because let me try another thing. So instead of ping, instead of finding the status of the local area network, let's find the status of a server that a website is running on it, such as vulnweb.com. So nmap, let me reset that, nmap ps sn vulnweb.com. As you can see, we are sending TCP requests to port 80. Let me stop it. We are sending TCP requests to port 80 because OneWeb is in distance and is remotely far from us, and we are not in the same local area network. Okay, so as I just told you, the best option to use if you want to scan and find out the status of the host in your local area network is the ARP, Address Resolution Protocol. But for the server and the host which is far from you, this TCP synchronized or TCP ACK is the most reliable thing that you can do. Also, alongside that, you can do ISMP echo request, ISM subnet mask address, and ISMP timestamp. So let's analyze that. We are sending, this is our IP address, and this is the target IP address. So how does it get the IP address from here? It does the DNS. It gets from the DNS server. I explained it in my previous video. If you didn't watch it, please go and watch it to find out how it works. And it sends from my computer. It sends a TCP synchronized to this target. And then the target responds with the SYN ACK. It means the port 80 is open on the target. And since we get the response, we just sent a reset flag because we don't want to establish the three-way handshake. We're just we're just interested in finding if the host is up or not. But remember that if you run nmap command as a privileged user like sudo or root, the TCP three-way handshake is never going to establish, and it's by doing that, it makes you more anonymous, it makes you more invisible, and you are kind of stealthy on the network because you are not establishing a three-way handshake. And after getting the response from the target, you send a reset flag, and you tear and how to say, destroy the connection. Okay, so this is the three things that we send. So now if I ping something like something else, nmap for example, google.com, let me, it's work, yeah, Google works, but let me redo it when Wireshark is up. Yeah, as you can see, the same thing, but we open different ports on our computer. Let me pause it. The same thing, we're sending the packet to port 80. We're getting the response from port 80. Seeing the port is open. RST, we tear the connection down, and we are good. So let me go back here. Yeah, that was for PS. We send TCP synchronized to port 80 usually. So, but now we have TCP acknowledge discovery. The PA flag sends a TCP ACK packet to a target port, usually port 443. If a RST received, the host is confirmed as up. No response suggests the system is either filtered or offline. So it's a usual thing that when you send a packet or a request with ACK flag set on, so you should always get RST request because you haven't established any connection. Because if you want to establish any connection using TCP, the first thing you need to do is to send a sync request. The first thing is sync request, then you get SYN ACK if the port is open, and then after that you send ACK or acknowledge to establish the three-way handshake. And if they send you RST acknowledge, it means the port is closed and you cannot establish a three-way handshake. But every time, always you send TCP acknowledge, because the system doesn't know this request, because you didn't send any sync request. So it says I didn't send you any message, or I didn't send you any packets. What kind of request is that? I don't know this message, the acknowledge message. So I sent you a RST flag, which is reset flag. So since we get the response, it means the host is up. And if we don't get any response, it's filter or the host is down. Works because firewalls may allow ACK packets through while blocking SYN scans. Sometimes the firewall blocks SYN scans, so the best alternative options to use is acknowledge. So let's also use this. So let me clear my screen. Let me reset the Wireshark, and same command, but instead of PS, it's PA. So as you can see, this is the first request that my computer sent from my IP address to this IP address. And I think it's Google, yeah? Yeah, it's Google. It's not OneWeb. And so instead of port 443, it sends exactly to the same port 80. Doesn't matter. And then it replies us with the RST ACK. It means the port is closed. Sorry, the port is closed. Yes, the port is closed because it's not SYN ACK, it's RST ACK. The port is closed. So we don't care about the port. Since the host reply us, we know the host is up and it's not down, or the ACK, the more important things, the ACK packet is not filtered by firewall. So why use multiple methods? So different network filter traffic, different networks filter traffic differently. Some like ISMP, as I explained to you, ISMP echo request is the most unreliable things because it's blocked by many routers and firewalls, specifically by Windows firewall. Some block SYN packets, some useful stateful firewalls, and some allow outbound web traffic. Using multiple discovery methods increases accuracy. Okay, so yeah, that's why you need to use multiple methods. Yeah, that's it. Let's go to the next slide. Uh, Default Nmap behavior is important when run with the root privileges. Nmap typically sends ISMP echo, TCP sync to port 443, and TCP ACK to port 80. And when we don't run the Nmap as a root, Nmap uses TCP connect method instead. Nmap adapts based on privilege level. So as I explained to you, if you run Nmap and if you want to do TCP sync, if you want to do PS or TCP sync packets, sync three-way handshake, if you are a privileged user, the three-way handshake is not going to be established because after getting the response, the valid response, I mean, sync ACK response from the target, it sends a RST or reset flag, and it tears down the connections. So it gets its response, it knows if the host is up, but it tears down the connection and it never sends the acknowledge. It never sends a package with ACK flag set on. So the usually three-way handshake is that the first you send the sync and you get the sync ACK or RST ACK, and then you send ACK if you get sync ACK. If you get RST ACK, so it's automatically the connection is torn down. So yeah, that's the default behavior on Nmap. It's really important if you run the Nmap on privileged user or as a unprivileged user. Host discovery versus port scanning. Host discovery means, in nutshell, is the system live or not? Port scanning means what services are running on it. This is a nutshell, and I try to summarize as much as I could. So, uh, we also done we have already done the practical things, but there's something left that I would like to show you. So if you're trying to scan the local area network, the best thing and the best option is PR, because it's use ARP protocol to find the host, and the way that you can do that is Nmap PR ARP protocol SN, the same range of the IP addresses or whatever that you want to use. And if I do the Wireshark here, if I send that, as you can see, I sent a lot of ARP requests. It's broadcast who got this IP address, who got this IP address, and somewhere I should get the response. Did I get? Yeah, I got it here on my terminal. So it should be somewhere here. ARP. For example, here, this is, let me mark it. For example, here we get the response. We said who got for this IP address, who got these IP addresses, and this IP address responds that I'm here with this MAC address, made access control address, and the others like this respond to us, this respond to us, also this responded to us, and if we check with our terminal, we should get the same result. For example, let me 42, which is here, and 243, 243, 243, and 240. Also, we got everything that we have on our terminal. We also have the same thing on Wireshark. I put the link for this website to check and see the different number and different type of the ISMP or Internet Control Message Protocol parameters. I will include the link in the section below. So we have already done the TCP sync discovery, TCP AG. So we also alongside the Nmap, we can determine which port we want to which port we want to scan, as you know, or which port we don't want to scan. We can do a lot of things with Nmap. I'm gonna create a playlist just about Nmap, beginner, intermediate, and advanced things. So it was just an introduction and basic things. Later on, I will talk about how you can specify a range for the port scanning, what port your port that you specifically want to scan, just a single port or range, a different range of port. So I will upload another video for that later on, but for now it was just a basic and introduction to the Nmap. So yeah, this is the response receive and the packet flow that we already talked about. Seeing RST or response received status update, we already talked about the packet flow concept. So in security perspective, from an attacker view, like the passive reconnaissance that I explained in my first video, host discovery identifies potential targets. So by doing that, especially using a tool like Nmap, you can find the services and the approximate version of that services. From a defender view, understanding discovery helps config firewalls properly, and reduce exposure and detect reconnaissance attempts. So So we have two perspectives, attacker and defender. These are two important perspectives that you should always consider them when you want to use tools or you want to gather information or if you want to do attacks. Uh, it's packet flow, next one. So yeah, that was all for this video. I hope you enjoyed this video. Um, if you want to tell me something that I don't know, I missed something in this video and you want me to record for the later on, please leave me a comment and tell me what kind of video are you interested in and what topic should I cover next time. So that was all for this video. Hope you enjoy it. So don't remember, um, practice make perfect, and always use Wireshark to follow and control the packets and the methods that you use. It's a really good thing. So in summary and in a nutshell, if you want to scan the remote and the remote and the server which is far from you, use TCP sync, TCP ACK, and ICMP echo request and ICMP timestamp or ICMP mask. But if you are in a local network, the best option is ARP request, address resolution protocol. It's way more reliable than the other things in local area network. So that's all. Thank you. Hope you enjoy it. See you later. Hope you have a very good time. Goodbye for now.